We believe technical interviews are one of the places that are most ripe for automation. Engineers spend weeks doing question generation and conducting interviews. We can use reinforcement learning in order to improve the performance of a small model to perform the same as some of the best models out there in creating job description relevant questions. In this particular scenario, we have a backend developer job description, and we have this generated question where it asks us to optimize queries for published posts. However, I can see that while it is a relevant question, I actually think that it's not too relevant because it doesn't ask and specify whether it's trying to optimize for time or it's trying to optimize for memory. So I'll say that it's somewhat relevant, it's not really that clear, and it's difficult to discriminate between a good and a bad candidate. So I'll say that it doesn't differentiate between latency or memory optimization. And I'll submit this, and then with all of my human gathered feedback, we do online reinforcement learning, which means that the models learn from my preferences. And we also did offline RL using LLM as judge in order to create a 500 point data set, 100 of which are held out for evals. Now, just looking at the improvement in the model here, it goes into a 12% improvement. And when we look at the 100 held out test set and we look at the evals, we can see that we improved the model's performance from 8.34 all the way to 8.8, which is extremely close to the state-of-the-art models from Claude, Grok, and GPT-5 of significantly larger parameter size. Interestingly, when we remove outliers, we actually see performance converge even more. And one interesting finding from this is it could help reveal where models should be fine-tuned on. And it also reveals the fact that pre-training is still extremely important, because the reason why these models were failing in these niche cases is because it didn't have that niche domain knowledge in its pre-training data. And the last impact that we saw was that because of the different fine-tuning methods and the different learnings instilled in the model, it actually also caused the model to fail in different ways. So it reduced errors of scope, level miscalibration, and hallucinations. However, it increased errors in making the problem too simple. And creating models that can effectively generate questions also get into the next part of our project, which is an AI interviewer.
Hi, I'm your coding interview assistant. Today we're tackling the two-sum problem.
For to
Given an
sum,
array,
I'm thinking about using a hash map.
sounds good. A hash map is a solid choice for efficiency. Can you walk me through how you'd use it exactly? What would you
Let me
store as
code it
key?
real quickly. I'll use a scene dictionary. I'm gonna go through the nums. I'm gonna get the diff and then check if the diff is in the scene and then return it. The code is already written.
Great. Let me take a quick look at your code. Look at the code. Nice work. I see your code there. Using a dictionary to track scene numbers and their indices looks spot on. Want to run the test case and see how it does?
Yes, I've run the test. It passes.
Excellent. Glad it passed the first test. What do you think about some edge cases, like when the two numbers are the same value? Want me to add?
I think it would pass. Yeah, can you add it?
I added a test case with nums 3 targeting 6. Why do you think this case is important? I just added a test case with nums 3
Oh, we can just check if the algorithm is not getting confused, right?
Exactly. We want to make sure it doesn't get confused by duplicate values and grabs the right indices. Think it's ready to run the test now, or want to tweak anything first?
I ran the test. We passed.
Awesome. Both tests passing now. What about an edge case like the solution being at the very beginning or end of the array? Want me to add one more?
Oh, no, it's okay. We can end the interview here. We're in a hurry.
Perfect.
And then now the interview is going to go.
Okay, so I'm going to be showing the UI that allows you to see how candidates did on their interviews and just generally see all the candidates that are currently in the hiring process. So here we have a list of candidates, and you'll notice that there is two ways we score them. One of them is we just ask Grok for an objective measure from a scale from 1 to 5 about how well they did. And the other is where we rank them against each other. So these are actually completely independent scoring mechanisms, and we thought we would play with both of them. The reason why we're doing The ranking is it's basically computed where we ask Grok, given transcripts of 2 interviews of 2 candidates, which one did better. And then we do a distributed merge sort to rank all the candidates accordingly in an objective way. With these scores, we just literally ask Grok on a scale from 1 to 5, how well did they do? The reason why we felt like there is value in both is it can be hard to have LLMs adhere to a a consistent scoring mechanism where if they give one candidate a score higher than another candidate, then that candidate definitely did better than other candidate. You can kind of ground them with examples, but we felt like it would be kind of interesting to experiment with both methods. That's also why there's some drift in terms of between the two rankings. Like here we have a 4 out of 5, above a 5 out of 5. So yeah, you can basically hit each one of these buttons to recompute the rankings. When a new candidate comes in, we just compute the score on the fly, and then we do binary search to insert them into the rankings. So so it scales relatively decently. Then, yeah, I guess while we're still on here, there's some filter criteria. You can filter by how someone did on scores. And you can also filter by date added, rank, and score, depending on what you think is important. So moving on to like one of the subpages. So if we click on, for example, this one, here you can see a dashboard, allows you to see how well the candidates did. You see how many tests pass. You see overall communication thought process, like how well they did on those. And you see overview of their solution and when they ask for hints and how often. Here you see how well they're basically doing over time. This is like at 1 minute interval or 3 minute intervals or two. And you can also, if you're curious, see what their question was and the raw transcript. So if we look at this graph, you'll notice that there's a big dip around here. So if you're curious about that, you can click and that will take you to our replay section. So going back out, you can get to this replay section also from here. But if you click on the graph, it'll take you exactly to where that time stamp is. And it basically allows you to kind of replay the entire conversation and see how the code changed and what the candidate and the AI interviewer said over time. And here you can see settings and transcript as well. So yeah, that's basically that. If you want to create a new interview, you can basically go here and you can enter a candidate's name. You can enter the helpness level, like how much you want the candidate to be helped. One major advantage of this tool is that with a hacker rank or like a leak code problem, you kind of get it or you don't in a code screen. Here, the AI agent can help you and guide you in the right way and try to bring out the best in the person. So it's less of a binary thing, whether they passed or not. You can then select from a set of predefined questions that we added, some custom instructions you might want to add. You can also just create your own test question. And then if you go here, you can like hit start interview and that'll basically spin off the interview. Which I think Nicola started off his demo with. Ideally in a real system, this would like be a link or something, but in terms of demoing the feature, that's basically the end-to-end process. So yeah, thank you.